Hello and welcome to another Creative Design and Innovation lesson. My name is Mariam Malas and I will be guiding you through this video. This video is about energy conversions from the chapter Renewable Energy and Sustainability. Let's have a look at the learning objectives for today's class. As a student, you should be able to understand the principles of energy conversion, to examine the laws of thermodynamics, the first law to be specific, and to be able to perform energy efficiency calculations. As for the keywords, it is important to know the definition of the following. First law of thermodynamics. Energy can neither be created nor destroyed. Energy efficiency simply means less energy to perform the same task, that is, eliminating energy waste. But before we start our lesson, how about the session on food for thought? Why do we sweat when we exercise? Think in terms of energy conversions. Well, we have established from last lesson that energy cannot be created nor destroyed, but it can go elsewhere. As the person exercises, most of their stored energy is released in the form of thermal energy. This is why people get hot and start to sweat when they do physical activity, such as running. Let's talk about energy conversions. We stated earlier that almost every form of energy can be converted into other forms. For your assessment number 1, try to write your thoughts on this diagram. You may pause the video if you think you need more time. When energy changes between potential and kinetic, it's known as energy conversion. Heat is also given off during the process of all energy conversions. A good example of this that we all have experienced is exercise. When you go for a run, you soon start to feel warm. If you were to feel your forehead while running, it would quite likely feel very warm. You would also be sweating. This heat is given off from the process of the conversion of potential chemical energy from the food we have stored into kinetic, mechanical, and electrical energies needed for us to move. The sweating is the body's way to try to cool us down. In the next slide, you will watch how energy conversions happen in a storytelling manner. Shall we do another assessment? I think we should, to ensure you have grasped all the information needed to move forward. Complete the sentences below using the following words. You may pause the video for more time. Yes, good job! Energy conversion, first law of thermodynamics. Energy follows the first law of thermodynamics. Can you recall what was the first law of thermodynamics? First law of thermodynamics states that energy can neither be created nor destroyed. However, they may be in different forms. We should keep in mind that with all the energy conversions, you end up with the same amount of energy coming out of the conversion as you had going into the conversion. The quantity of energy may be the same after energy conversion, but the quality is never the same. Let's look back at our earlier example of exercising. When running, the chemical energy in food is converted to mechanical and electrical energy. Then it is dissipated as heat, which is lost to the air. Let's go ahead and start with energy efficiency calculations. To calculate energy efficiency, we use the following formula. Efficiency percentage equals output energy divided by input energy times by 100. Practice time. Let's do one example together and see if you understood this lesson content. A chemical process has an input of 140,000 joules and an output of 5,600 joules. What is the conversion efficiency of this process? Well, the answer is as follows. Efficiency equal output over input times 100, with output being 5,600 joules and input being 140,000 joules. Please perform the calculations and try to obtain the results. You think you got it? Let's do an assessment as a final activity to end today's session. An electrical motor has an input of 100 watts of electrical energy to obtain 90 watts of mechanical power. Calculate the efficiency of the electric motor. You may pause the video for more time. An electrical current delivers a power of 60 watts to a light bulb. 3 watts of electrical energy is transferred to light energy. Calculate the efficiency of the bulb. You may pause the video for more time. Time for a recap of the learning objectives. By now, as a student, you should have understood the principles of energy conversion, examined the first law of thermodynamics, and performed some energy efficiency calculations. I really hope you enjoyed today's session. Thank you and have a nice day.